As the Q-SYS Designer software continues to grow, new control components get added with new version releases. Let's take a look at some of the control components that weren't available when we first filmed this training course, which might be exactly what you need. Scheduling something to happen in Q-SYS based on a particular time or day of the week is traditionally accomplished using the Administrator tool, where you can use the command scheduler to target named controls, activate snapshots, launch PA announcements, and more. But if you wanted to do this within the design itself, you were typically restricted to something like this, using the date-time component and comparing its output to a custom text field using a string equal control function. And if you wanted to get more granular with your control, you'd probably have a mess of additional logic components just to accomplish something simple like shutting the system down every weeknight. Even using scripting components wouldn't make this significantly easier because you'd still have to build out each condition individually, and you'd have to update the code if you wanted to change the schedule. So we made the when component to save you from all this effort. It's quite simple. You just choose which days of the week and the time that you want an event to occur and enable it. When the time matches, the active LED will become true, which you can use to activate any number of automations within your design. You can also customize how long you want to hold that LED in a true state before it resets to false. So I can quickly just select Monday through Friday, enter 2200, and yes, please note this is a 24-hour time format. There's no AM or PM. And now I've automatically got an LED I can wire to anything in my system, such as a snapshot load button, third-party plugins, etc., to turn my system off each evening. Making changes to that schedule is very easy, and you can put all of these controls onto a UCI so the user can make these changes for themselves. If you're getting into more complicated scheduling, like an event that repeats every 2 hours or has to happen on the 12th day of every month, then the Administrator is still the more robust tool. But the when component makes simple timing automation quick to accomplish and easy to customize for the end user on a UCI. There are some cases, however, when the when of when you want to do something may be variable based on the time of year. For instance, you may want to change the CSS theme of your UCI from a light mode to a dark mode using the UCI style controller. Hey, look, I'm sneaking in another one here, when the sun sets. But the sun sets at different times throughout the year, and you don't want to have to keep updating that. The astronomical clock gives you trigger outputs for sunrise, sunset, and solar noon, as well as a Boolean LED that is on during daytime and off at nighttime. This is all determined by your latitude and longitude, which you can either input manually or get if your core has access to an external network. Between this and the when component, you can truly make sure your system is automated based on the time of day anywhere in the world. You might think of the sequencer component as an upgraded version of the control delay. We previously showed you how a control delay can take an incoming signal and then transform that into multiple outgoing signals, each delayed by a certain amount of time, which is great for allowing a single action to result in a series of results based on your desired timing. Well, the sequencer takes that a step further. You can still customize how many outputs you want, but the sequencer gives you individual output LEDs that are turned on in sequence and remain on based on their own customizable length parameter. So do keep in mind that the active LED goes false again when its step is complete. So if you want to activate something that is also a Boolean control, like another toggle or LED, be aware that this will turn it off again too. Whereas if you wire the outputs of the sequencer to trigger buttons, that's a great example of how you can use the rising edge of a toggle button to activate a trigger button, whereas the falling edge, when the toggle turns false again, will have no effect on the trigger. Another difference between the sequencer and the control delay is that the sequencer genuinely operates in sequence. With a control delay, all delay timers essentially started simultaneously, whereas the sequencer does not move to its next step until the previous step is complete. And if you need a delay between steps, you can customize that as well. Most importantly, the sequencer has a stop control. So if you need to interrupt the sequencer while it's operating, all you have to do is activate that momentary stop button. This was something the control delay couldn't do. Once the control delay input was activated, nothing could stop it from finishing its task short of a random, violent power outage. You can also set the sequencer to loop by changing its properties so that it will run in perpetuity once it's started until you stop it. The applications here are limitless, not just from sequencing short-term events, but long looping delays could let you do something like slowly change the color of your coworkers' lights by a tiny amount once a week until after a year they think they're insane because didn't those lights used to be blue? No, Jimmy, they've always been green. You're the crazy one. But let's look at something more realistic. Let's say you want to start a 60-second timer after a user turns off the display in their conference room. And at the end of that 60-second timer, you want to send a command to turn the lights off in the room and reset it so that it's ready for the next occupant. But if any activity is detected on the touchscreen controller in the room, you know they're still in there doing something. So we'll use that screen touch activity in the room to stop the sequencer. And then, hey, guess what, control delay? You're still useful. We'll use you to trigger the start button again a moment later, essentially resetting the 60-second timer every time the user interacts with the UCI. Of course, we only want this to happen after they turn off the display, not during their meeting. So let's add a logic AND to make sure the touch activity only activates the sequencer if the display status in the room is not on. Remember, whenever you're building automations into your system, spend some time troubleshooting all the possible conditions the system could be in to make sure you've covered every eventuality. We haven't covered every single control component in these videos, so if you see one that looks interesting to you, be sure to check out the help file to read all about it. See you next time.